All right, so in this part C of the problem, we want to find what the probability repairs will exceed $75 a week are. I skipped part B because I don't want to do the graphing stuff, and I'm not going to test over it. So I meant to actually just take it off of the review, those types of problems, but obviously I missed this one. But so sorry about that. But in part A, we found that C is equal to 6. So that means that our f of x, we can just plug that in, is going to equal 6x times 1 minus x. And this is when x is between 0 and 1. And it's going to be 0 otherwise. And now what do we want to do? So we want the probability that, remember, x is in hundreds of dollars here. Our repair costs are in hundreds of dollars. So if we want the probability repairs will exceed $75, that's the probability that x is going to be greater than 0.75 because it's in hundreds of dollars. So this is going to be the integral now from 0.75 to infinity, our density function f of x dx. Remember, in this specific case, our density function only takes non-zero values between 0 and 1. So in our case, this is going to be that we're integrating from 0.75 to 1, and then our density function is 6 times x times 1 minus x, sorry about that, dx. So let's pull the 6 out, that's just a constant, and then let's distribute the x in there. So this is going to be equal to 6 times the integral from 0.75 to 1, and now we're going to have x minus x squared dx. So I know we just did this integral in the first part of the problem. So at some point maybe it makes more sense to do the CDF if you're having to the cumulative density function if you're having to do a lot of these probabilities. But anyways, that's okay. So this is going to be 6, and now when we integrate, we add 1 and divide by the new power. So we add 1, we get x squared, and divide by that new power of 2. And then we do minus, we do the same thing, add 1, x cubed, over the new power of 3. And we're evaluating this from 0.75 to 1. So now how do we evaluate this? We plug in the top number, and then we subtract off plugging in the bottom number. So we plug in the top number, we get 1 squared over 2, which is just 1 over 2, minus 1 cubed over 3, which again is 1 over 3, minus plugging in the bottom number. So this is 0.75 squared over 2, minus 0.75 cubed over 3. So we can plug that in. So this is going to be 6 times, in parentheses, 1/2 minus 1/3 minus, in parentheses, 0.75 squared over 2 minus 0.75 cubed over 3. I think that should be good. So I got that this probability is 0.15625. And that is it for part C.